Okay. Due to the situation in the country, right, we have decided to conduct the lessons in this manner. So, as a start, I have uploaded the unit number 4 as a quote to the group. So, what you can do is you can either print it or prepare the notes in your book according to the quote I have given. Now, even if you have printed, it is better to paste it on your textbook because the printed quotes can be misplaced. So your writing book will never going to be misplaced. So therefore, it is better to paste it on your writing book, not the textbook, right? Sorry, in your writing book and keep it. So if you have already printed in both sides, you can apply some glue here on the line and paste it on the book. Okay. So that's the best way to do it. Now the lesson number 4, waves and their applications. Now this is a physics lesson, right? So when it comes to the waves, it is not a new word, right? We'll go through with the tube. In our day-to-day life, we come across many occasions where we find waves. Example, when we put a pebble onto still water, ripples form on it. Ripples form on it. So the diagram is here. I'll show you. Here, this is the diagram related to that. Once you put a small piece of stone or something under the water, on the surface, there will be ripples, rally appear. So those are kind of waves. Then the second one, ripples form when moving a rope up and down, which is fixed onto a tree. So the third diagram, once you move the rope up and down, we'll see there's a wave going on it. Then waves in the ocean. Now here you can see the diagram of the ocean, and we regularly see the waves appearing on the surface. Okay, then we'll go with the tube. Such a disturbance propagating through a medium or space is known as a wave. So the wave is a kind of a disturbance which occurs in a certain medium. It can be a surface of water, it can be air, like that. Put small piece of paper when a wave is appearing on it. We will observe that they move up and down. So when there is a wave appearing on the still water surface, and if you put a small piece of paper or rigiform onto the surface, you will see that they will move up and down. So in order to move a piece of paper up, there should be some amount of energy. Right? There should be some kind of an energy to lift it. So in other terms, waves are taking energy with them. In other words, energy is transmitted by waves, but there is no movement of particles with the wave now. As you can see, the piece of paper is sort of a particle, right? It moves just up and down. It is not going to go along with the wave. They are just moving up and down. That's what I said. The particles are not going to move continuously with the wave, but they will show some kind of a vibration. But here in this case, the water waves, the wave is moving in this manner, and the particles move up and down. So the piece of paper representing a small particle. Then we come to wave motion. So waves are always in motion, right? Waves are not staying in one place; they will move. Two waves we discuss propagate through a certain medium, such as water and rope. So we are referring to the above example, right? They are certain materials. So the water and rope, they are type of material or matter, phase of matter. The motion of particles of the medium transmits energy in the form of a wave, though the medium even through the medium, even though the particles themselves do not travel along the wave. That's what I earlier explained. So when I talk, the sound wave will move, but the air particles will not move with it. So if that happens, when I talk, it will be like switching on a fan. So large wind will come. That will not happen. Only the sound wave comes, not the particle. Waves transmit through matters such as solid, liquid, and gas. So the waves are capable of transmitting through all the three states of matter. We hear due to sound waves. Uh, okay, so you can listen to my voice. So my voice is kind of a sound wave. It takes energy with it. So when the sound wave hits on your eardrum, it vibrates and will hear my voice. We hear due to sound waves, they propagate through solid, liquids, and gases. So there were previous examples in your previous grades proving that the sound waves can be propagated through solid, liquid, and gas. There are waves that do not require a medium for propagation. They are called electromagnetic waves. Now, up to now, the waves that we talk about, the sound waves, the water waves, they all require a material medium for the propagation. For an example, sound waves will travel within solid, liquid, and gas. But when you go to outer space, the astronauts, when they are outside of the spaceship, they cannot talk to each other using sound waves because there's a vacuum. That means nothing. So in that case, the waves that we discussed, especially the sound waves, they require a medium for the propagation. Otherwise, they will not move. But there are another type of waves which do not require the medium in order to propagate. Even though there's a medium, it will not get the help. They are called electromagnetic waves. So one of the best examples is the radio waves, then the light rays, right? Now, if you think of sun and the earth, uh, actually the earth is somewhere around 150 million kilometers away from the sun. So in that gap, the light energy, the light rays will travel without a medium. It's just a vacuum, nothing is there. So electromagnetic waves, they are capable of moving or propagating without a medium. Then again, radio waves also are the same. So Earth is communicating with satellites through a vacuum. So the electromagnetic waves, the radio waves, they are coming under this category. Electromagnetic waves, radio waves are coming under that, but sound waves are not coming under that. Even if there's a medium, electromagnetic waves propagate without the help of it. Example, light waves, radio waves, X-rays, infrared radiation. So we are going to talk about the electromagnetic radiation and the waves in detail within this lesson in a few moments. So then we are going to talk about one of the two types of waves, the mechanical waves. So they require a medium for the propagation. That's why they are grouped under the mechanical waves. We can explain mechanical waves as follows. So these are the gaps you can fill with the help of the textbook. So we'll go to the textbook. Right here. This is the one here, right? Waves that need a material medium for propagation are known as mechanical waves. I'll repeat. Waves that need a material medium for propagation are known as mechanical waves. So you have to write that sentence in this box. Okay. Right. So since you can post this and complete it, I'm not going to give special time for writing. It's a waste of time and your data. So therefore, I'll continue teaching. When you want to write, you can just pause and do it, or else you can look at the textbook and write. So don't. I will not give you extra time for writing. To explain this, we can use a slinky. Now, slinky is kind of a spring-like thing, right? You have seen springs. So slinky is a very flexible spring where you can pull it, stretch it, or press it closer to the gate. It is made out of steel and highly flexible. So what you can do is you can stretch it on a table, tell somebody to hold from one end, and you can move it left and right. So when you move left and right, you will see a wave is appearing on it. A wave is appearing on it, right? So S-shaped thing, or the shape of a wave will move along with the sling. Right. So that's what explained here. Now here, the end of the slinky is moved left and right, and the wave is continuously moving along the sling. Right. Here I will give you a note. You can write from here. Stretch a slinky. Stretch can adino. STRETCH. Stretch a slinky. Stretch a slinky. SLINKY. Stretch a slinky on a table. Stretch a slinky on a table. Hold it tight. Hold it tight. Hold it tight from one side. Hold it tight from one side. And move the other side left and right. And move the other side left and right. And move the other side left and right. We can see a wave propagates. We can see a wave propagates. PROPAGATE. Propagate. A wave propagate along the sling. We can see a wave propagate along the slinky. Okay, nothing much right there. Then we come to the other part. Participation of particles in a medium is necessary for the propagation of a mechanical wave. Right? So that's what we said. Mechanical wave, they require a material medium. So they need the particles. Based on the direction of motion of particles of the medium and the direction of the propagation of the wave, mechanical waves can be divided into two categories. So, based on the movement of the particles of the medium and the direction of the wave motion, we can categorize waves into two groups. They are transverse waves and longitudinal waves. So, those are the two names you have to write in these two small boxes. So, these are the words you can see the screen: transverse waves and longitudinal waves. Transverse waves and longitudinal waves. Okay, we come to the transverse waves. Now, the transverse wave, the relationship is the particles of the medium will oscillate perpendicular to the direction of the motion of the wave. I'll show you the meaning. If the wave is moving along into this direction, right, the particles of the medium will move perpendicular to the direction of the wave. The wave is moving in this manner, and the particles will move up and down. So the particles are not going to go along with the wave. They are just moving up and down. They are not going to move along with the wave. Okay. Right. So here in this box, you have to write the definition for the transverse waves. It is given in black color letters, bold letters, so you can write it. I'll show you. Waves that propagate in a direction perpendicular to the direction of particles of a medium move are called transverse waves. Waves that propagate in a direction perpendicular to the direction of the particles of the medium move are called transverse waves. That's what you have to write in that box. Right. Now there's an activity. So we are going to observe whether the definition is true. We are going to check whether the particles move perpendicular to the direction of the wave motion. So in order to do that, again, we need a slinky and a few pieces of ribbon. So what we do is we take the slinky and tie several pieces of ribbon at several places. So that's what we do. Then we can, yeah. So here in these lines, you can write things needed, things needed. These are the things needed. A slinky, a few pieces of ribbon. So that's what you can write in that front lines. After that, I'll explain how to do the activity. So we can write here. Stretch the slinky on a table. Stretch the slinky on a table. stretch the slinky on a table, and tie, TIE, and tie several pieces of ribbon, tie several pieces of ribbon tie several pieces of ribbon tie several pieces of ribbon onto it. Several pieces of ribbon onto it. Move it left and right. Move it left and right. Move it left and right. And we can see, and we can see, and we can see the pieces of ribbon, the pieces of ribbon move, pieces of ribbon move perpendicular to the direction, perpendicular to the direction of the wave motion, perpendicular to the direction of the wave motion. Right, now here again, there are two diagrams you should draw, and then we go back to the textbook. Now, these are the two diagrams. Now in the first box, small box, you have to write this. So I draw it on the board already. So the blue color line represents the direction of the wave motion or the propagation of the wave, and the red color lines representing the movement of the particles. So they will move up and down, which is perpendicular to the direction of the wave. Right, then the second diagram shows you the cross section of a water wave. So the arrows will show the direction of the movement of the particles, and there are certain places which are high up. They are called crests, and there are some downward places, right? They are called troughs. So when the transverse wave moves, there will be crests and troughs. So they will be altered. So the crest will turning into a trough, then the trough will be turning into a crest. That's how the particles move. Okay, so you can draw the two diagrams in that two boxes given here. So then come to here. In the water waves generated by disturbing a still water surface by dropping an object such as a pebble, water particles of the medium move up and down within a certain range, while the wave travels in a direction perpendicular to that. So we explained that. The wave propagates on the surface of water is a transverse wave. This diagram explains about the particle motion and the direction of wave propagation. Right. So the first diagram. Below figure shows the cross section of a water wave appears at a given instance. The arrowheads indicate the direction that the water particles are moving at that instant. So we have drawn the two diagrams, and again, the particles at point A and B have traveled the maximum distance in the upward direction. Such points in a wave are known as crests. The particles at C and D have traveled the maximum distance in the downward direction. Such points are called troughs. Again, the same thing can be observed by a rope which is tied onto a certain place and moving up and down. Right. So that is the information regarding the transverse waves. So we'll continue the lesson in the second video from the longitudinal waves. We'll continue with that. So this is the end of the first section of the lesson.